As promised, this is a solution to the question from the worksheet. In a certain chemical process, a substance is being formed, and 2 minutes after the start of the process, there are m grams of the substance present. In the process, the rate of increase of m is proportional to 50 minus m to b squared. When t is 0, m is 0, and dm dt is equal to 5. Part 1 of the question asks to show that m satisfies the differential equation. So, the rate of increase is always dm dt, or the rate of increase of m is dm dt. So, dm dt is proportional to 50 minus m to b squared. And in order to remove the proportionality sign, we need to have a constant of proportionality. And we let that constant of proportionality be k. So dm dt is equal to k into 50 minus m to b squared. And they gave you conditions. So when m is equal to 0, dm dt is equal to 5. So we're going to make our substitution. So 5 is equal to k into 50 minus 0 to b squared. So k by 50 squared is equal to 5. So k is equal to 5 over 2500. Which is equal to 0.002. So therefore, dm dt is equal to 0.002 into 50 minus m to b squared. Part 2 of the question asks to solve the differential equation and show that a solution can be expressed in the form m is equal to 50 minus 500 all over t plus 10. Now from part 1, dm dt is equal to 0.002 into 50 minus m to b squared. So let's bring across the 50 minus m to b squared and take across the dt. So dm over 50 minus m to b squared is equal to 0.002 dt. So we can say that this is of the form f of m dm, which is equal to g of t dt, where f of m is equal to 1 over 50 minus m to b squared, which is a function of t only, which is a function of m only. And g of t, which is equal to 0.002. Again, it's a constant, but it could also be a function of t only. So this is of variables of separable form. And solution is found by integrating. So therefore, the integral of dm all over 50 minus m to be squared is equal to the integral of 0.002 dt. And when we integrate, this should be 1 over 50 minus m, which is equal to 0.002 dt. Sorry, 0.002 t c. Now, just a quick side note. The integral of 1 over 50 minus m to be squared dm, that's really equal to 50 minus m to the minus 2, and that is equal to, so it's 50 minus m to the negative 1 all over negative 1 by negative 1 plus c. Let's take out the plus c for now. So that's really 1 over 50 minus m. Now they also give you some initial conditions in the question. So when t is equal to 0, m is equal to 0. But before you, let me mention here that this is what we know as the general solution. Continuing, so when t is equal to 0, m is 0. So what do we get? We get that 1 over 50 minus 0 is equal to c. So c is equal to 1 over 50. And let's make our substitution. So 1 over 50 minus m is equal to 0.002 t plus 1 over 50. And 0.002 t is equal to 1 over 500 by t. So let's make that substitution here as well. So 1 over 50 minus m is equal to t over 500 plus 1 over 50. Take the LCM, which is 500. So this is t plus 10 is equal to 1 over 50 minus m. Inverting both sides, so you're going to get 50 minus m is equal to 500 over t plus 10. So m is going to be equal to 50 minus 500 over t plus 10, which is exactly what we wanted to show. Part 3 of the question asks to calculate the mass of a substance when t is 10 and find the time taken for the mass to increase from 0 to 45 grams. So let's recall that m is equal to 50 minus 500 over t plus 10. So when t is equal to 10, m is equal to 50 minus 500 all over 10 plus 10. That's 50 minus 500 divided by 20, and that will give us 25 grams. So now we have to find the time taken for the mass to increase from 0 to 45 grams. So initially, when m is 0, t is equal to 0. So let's now find when m is equal to 45. So when m is equal to 45, that is 45 is equal to 50 minus 500 all over t plus 10. So let's take across the 45, carry across the 500, and 50 minus 45 is 5. So you get 500 all over t plus 10. So t plus 10 is equal to 500 divided by 5, that's 100. So t is equal to 90 seconds. So it takes 90 seconds for the mass to increase from 0 to 45 grams. And the last part of the question asks to state what happens to the mass of a substance when T gets very large. So again, m is equal to 50 minus 500 all over T plus 10. Now as T gets very large, what it implies is that T tends to infinity. 1 over T plus 10 will tend to 0. Or as you see, as T gets large, 1 over a very large number, it becomes a very small number. So that also, since 1 over T plus 10 tends to 0, 500 over T plus 10 will also tend to 0. And then m will tend to 50. So as T becomes very large, the mass of the substance being formed gets closer and closer to 50 grams.